Okay, now we're going to look at problem number 2, dealing with exponents. This is on boat stability. So the problem says the weight of a boat depends on its beam width. An equation that relates a boat's weight to its beam width is W equals 64 times the quantity of B over C to the third power, where W is the boat's weight in pounds, B is the beam width in feet, and C is the capsize factor. When the capsize factor C is less than 2, the boat is less likely to capsize or turn over. So that's just, here's a formula, and they're explaining what each part of the formula means, which will help you use the formula. And problem number 1 is just asking you to use it. Suppose that a boat has a capsize factor of 3 and a beam width of 6 feet. What is the weight of the boat? Okay, so this is just a matter of substituting, right? We know that if capsize factor of 3, then we know C equals 3. Beam width of 6 feet, that means, and we always check your units, feet and feet. Okay, so we know that this is written in the right units for this formula, so B equals 6. So now we just need to plug it into the formula. W equals, we still don't know the weight yet, but W equals 64 times, and now B over C, but here we have actual numbers for B, 6 over C, 3, all of that to the third power. Once we substitute in, it's just a matter of order of operations, right? You do grouping first, so 6 divided by 3 is 2, so we can rewrite this. W equals 64 times 2 to the third. Then you do exponents next. So 2 to the third is 8 because we're doing 2 times 2 times 2, right? That means 2 times itself 3 times. 2 times 2 times 2 is 8. And then you just do 64 times 8. And obviously, use a calculator if you need to. So 64 times 8 is 512. And we need to interpret it in terms of the problem. So we go back, well, weight is in pounds. So the answer is the weight of the boat is 512 pounds. Okay? So the next problem, if you turn over your page, is the same kind of problem. Number 2, suppose a boat has capsize factor of 3 and a beam width of 9. So it's really only changing this part. So I want you to do number 2 on your own. And then 3, explain how you calculated answers to questions 1 and 2. This is just telling you to use words to explain what you did here. So do that on your own. I'm going to go ahead and move on to number 4 on this. Suppose that a boat has a capsize factor of 2 and weighs 1,000 pounds. Now this is a little bit different. Up here, we knew the capsize factor and the beam width. Down here, we know the capsize factor and the weight. So we know that C equals 2 and the weight equals 1,000. So when we plug it into the equation, it's going to look a little bit different. We put 1,000 where the W is, right? And that equals 64 times, and this time we don't know B, so we write a B, that's what we're trying to find, the beam width, over 2, all of that to the third power. So this just told us to write an equation that we can use to determine the beam width, and we did that. Here's an equation we can use to determine the beam width. So we have finished part A, but now this says transform the equation that you wrote to isolate the variable with its power on one side. So here's the variable, and we want to isolate it, okay? And notice she's giving us a hint about a rule. She's reminding us that when we have two things being divided, both raised to a power, we can raise both of those to the power. We can rewrite it as the numerator to the power and the denominator to the power. So let's use that, okay? We're going to rewrite this equation. I'm going to leave 1,000 the way it is. I'm going to write 64 the way it is. But then I'm going to multiply. I'm going to write B to the third power over 2 to the third power. I'm going to use the rule, that little hint she gave us. Okay, now that I did that, I can go ahead and calculate 2 to the third. So I'm going to rewrite everything the same, but 2 to the third is 8. Okay, and at this point, I can do 64 divided by 8, right? Because this is like 64 times this divided by that. So 8 goes into 8 once. 8 goes into 64 8 times. So I can rewrite this equation now as 1,000 equals 8b to the third. And remember, the whole point is to get this variable with its exponent all by itself. So last step, I just need to divide by 8 on both sides. And dividing by 8 on both sides, 1,000 divided by 8 is 125. And that equals b to the third. So we transform the equation to isolate the variable with its power, and we've finished what they told us to do. But now C is saying we really still haven't found the beam width, right? So C is kind of walking us through how to do that step by step. To determine the value of B, you have to know the number that when multiplied by itself 3 times is equal to 125. So what times itself 3 times, right? What number, when I do b times b times b, is going to equal 125? That's the question. So what is that number? So we might just need to do some guess and check around that. Obviously, 2 times 2 times 2 would be way too low, because 2 times 2 times 2 is going to be 8. So 2 is too low. 10 times 10 times 10, that's going to be 1,000. Well, that's too high. So we need to look for a number in between those two, between 2 and 10. Now I want you to think that through for a second. And if you think about it, what kinds of numbers when you multiply it times itself is going to end in a 5? That's pretty much 5, right? 5 times 5 times 5. 5 times 5 is 25, and 25 times 5 is 125, right? So what number times itself 3 times gives you 125? 5. So what is the boat's beam width? 5. And remember your units. Remember at the beginning, back here, we defined the units in terms of feet, right? Beam width in feet. So 5 feet. Okay, so now moving on, they're telling us you can say that a number b is a cube root of a number if b to the third equals a. So here 5 is a cube root of 125. Because 5 to the third equals 125. So we've heard about square roots, right? Like 4 squared equals 16. So that means the square root of 16 is 4. Okay, so same thing here. This is just called a cube root when we're working with cubing a number or raising it to the third power. And we use this symbol right here, cube root. Okay, so the number 3 right here, it's called the index of the radical. So these signs, up until now, you've only seen square root signs, right? But anytime you have a radical, this is called a radical. Anytime you have that, here it's assumed the index number is 2 if you don't see one. But if you see an index number, if you see a number, that's called the index number. Okay, so cube root of 125 equals 5. So here, complete this statement. The cube root of 8 equals, so you have to ask yourself, what times itself 3 times is going to give me 8? So you figure that out. Same thing here, cube root of negative 27. What times itself is going to give me negative 27? You figure that out there. Now I'm going to move on down here. You can extend the idea of square roots and cube roots to solve equations. If n represents a positive number, then a number b is the nth root, right? So it's just saying anytime you have an index number, it's telling you how to compute that, right? 2 is the 4th root of 16 because 2 to the 4th equals 16. So 2 times 2 times 2 times 2 equals 16. So 2 is the 4th root of 16. So complete each statement. The number 3 is the 5th root of 243. Because if you take 3 to the 5th power, you're going to get 243. So that's what being a 5th root means. 3 times itself 5 times will give you 243. The number -2 is the cube root of -8, because if you take -2 to the 3rd power, you get -8. So fill in the blank about what kind of root 4 is with respect to 4096. So down here it's just a practice on using those ideas of square roots, cube roots, 4th roots, 5th roots, okay? So the square root of 100 is 10 because 10 squared equals 100, right? The cube root of 216. So think through what number times itself 3 times is going to give me 216. So you might just need to try out some numbers. Again, we know it's not going to be 2 because 2 times 2 times 2 is 8. We know 10 is too big, right? That'd be 1,000. So what number times itself 3 times? And 4, let's try 4. Okay, that's not going to work because that's too low. I'm going to use an even number, obviously, because we've got 6 here. So 6 times 6 times 6. Okay, so the cube root of 216 equals 6 because 6 to the 3rd power equals 216. So I want you to do C and D on your own. You're trying to figure out what times itself 4 times will give you 81. And you're trying to figure out what times itself 5 times will give you -32. And then the last problem, as part of problem 2, is this number 8. So it says, notice that a power can be positive or negative depending on the base and the exponent. When the exponent of a power is an even number and the base is a positive number, is the value power positive or negative? Okay, so let's do some examples. When the exponent of a power is even, so let's say 2, and the base is positive, so let's say positive 5, is the value of the power positive or negative? So 5 squared equals 25. Well, so it looks like it's going to be positive. Let's try a couple more examples. Exponent is even, right? So exponent is even. Let's try a 4. And the base is positive. Let's try a 2. So 2 to the 4th is 16. Okay, it's definitely looking like it's going to be positive. So how do you know? Because I tried a couple examples, right? And you might give the examples you tried. So you write out your explanation. It's going to be positive. How do you know? Because you tried out a couple examples. So here, let's try this one. When the exponent of a power is an even number, okay, so even exponent, the base is negative, so let's try -2. Is the power positive or negative? Well, -2 times itself, -2 times -2 equals +4. Let's try another example. Power is even, so let's try 4th power. Base is negative, let's try -3. So that's the same thing as -3 times -3 times -3 times -3. Okay, let's think about this. A negative times a negative times a negative times a negative. That's going to be a positive, right? So I don't even really need to know what 3 times 3 times 3 times 3 is. I mean, it's 81. But the main thing is we're just trying to figure out positive or negative. A negative times itself 4 times is going to be positive, right? So how do you know? Either you can say you did a couple of examples, or you can say, look, anytime I'm doing a negative times itself an even amount of times, it's going to be a positive. So you write out the answer and explain. And then you do these two by yourself. Here you're talking about the power or the exponent being odd, and the base, this bottom part, being positive. And here you're talking about exponent being odd and the base being negative. So something more like this, okay? So you do C and D on your own.